Good morning. Let's have the attendance taking first.陳偉豪、趙家明。
喺度。
OK， 陳偉豪 here。趙家明。好，梁善維，梁善維 ，yes。李振傑、李彤。李振傑、李彤。李振傑、李彤 not here。吳晶豪、徐家榮。
喺度。
吳晶豪 here。Good morning。徐家榮。胡嘉龍。余入溫 Yes, okay, I see you. 翁正南 here, I know. Yep. And 6B, 陳俊熙、蔡俊明。
喺度。
You are
陳俊熙。
蔡俊明？Do you find 蔡俊明 ？No. 朱俊輝嚟運證。
喺度，早晨阿 Sir。
OK， 早晨。李健朗、盧少華。
喺度。
你係盧少華？
係。
李健朗 ，How about 李健朗 ？Yeah, here I see. 吳文希、温子維。
喺度。温子維
here, I know. Yeah. 吳文希 ，Yeah, here. 余子豪、袁天佑。
喺度。
係 OK. So, call upon those students again. 趙家明、李振傑。
喺度。趙家明喺度。
OK， 李彤、李振傑 ，Yeah， 李彤 ，How about Samson? Samson, not here. OK， 陳偉豪 ，Could you please help? Try to call him.
Okay.
Here. Woke up. Oh no. 唉。All right. So I just sent you 2 files. This is it seems it's a big box actually. In the NCAM. In NCAM, this topic because we have some modern instrumental method, right? Including IR, MS, right? All those they are just a little bit challenging, I must tell. Okay. So shall we have a start now? Just wait until Samson are ready. Are you ready? Can I have a start of lesson?
Yes.
All right. Good morning. Now, unit 54. You will see that file. Let me see. Do you receive the file first of all? Second, do you find the file? What a nice profile picture. Samson, what is that? Introduce that for me. Spider-Man? Yeah, it seems not. Yeah. So 54, instrumental analytical method test. This one. So I would like to briefly introduce this one to you, and you may find that every year this topic must be assessed. Okay, so all of you, could you please mark a star in this now? Please place bar star here. Every year that must be assessed. must be there. There must be run questions, but whether or not the mode of that questions will be a little bit different year by year. But what I want to tell you is that, well, this question must be there. Okay, no matter it is in part a short response questions or the long questions of integrated topic, or even separation of those two concepts, IR1 questions, MASBET 1 questions. I just want to stress it once again that this question must be assessed every year. Okay, so take a look at question 1. In which you need to get to know, or if you have IR and MS, you should know something about OChem QA for organic chemistry part. For IR and MS, you are going to have two different information. The first one, IR, what will you get about IR? 陳偉豪。陳偉豪。How about the one who just entered the classroom? Samson, tell me, what information do you get from the IR spectrum and MASBET respectively?
MASBET 就可以揾到佢嗰個 molar mass。
Molar mass. Okay. In particular, what we have is just an RMM, right? Relative molecular mass. I know the whole mass of that molecule. What else? Is it just this? Do you have any more? So how about this? Or you take a look on the MASBET, right? If you just said so, molar mass, where do you find the molar mass? Or LMM, relative molecular mass? Where is it?
最右邊嘅字咯。
The rightmost, this one?
最右邊長啲嘅字啊。
This one. Okay, how do we call that peak? How do we call that peak? Yes, I will find the RMM of this. How do I call that peak? No? We will say the word, start with the letter P. What's that peak?
錢上嚟啊！
Yeah.
我哋仲未收到嗰個 question answer book 㗎，應該年54。
I just sent you. Which one? I just sent you through WhatsApp. Do you find it? Let me see. 54 and 55. Oh, no. I know what's happening. I just sent wrongly to Form 4 group because they also call Chem 1. Oh, sorry about that. So your Form 4 brothers have started to know something about Form 6. I know why. Because every time, we just struggle for the determination of chemical formula quiz. So that the name has just been popped up into the WhatsApp. This is the very first few groups that appear on top. Yep, parent peak. Okay, parent peak. Choi Jun Ming. Good morning. Choi Jun Ming, good morning. So this is parent peak. How about this? is also high, right? In terms of intensity, nearly 100. So what is, so this is not the base peak. Indeed, the one which shows 100%, can you see that? This is also the base peak. So what a coincidence that two, they are the same, but they do not have the same unit. For base, what is the difference between the two? Base peak, parent peak. Parent peak, it must show you the relative molecular mass. How about base peak? They shows you the most intense peak. So which means that the height of the peak is the highest. So how come the peak is the highest? It received the most that type of ions or that fragments. So 29 is just one of the many fragments peak. Okay, so indeed, you may have some fragments. So from the fragments, I would know part of the structure of the molecule. Okay, this is what you know about the molar mass. Mass spec. Besides, I get molar mass, RMM, we will find the fragments. From base of fragments, I know the part of the structure of the molecule and use this pieces of information and try to measure overall to get the overall picture. Okay, so this is the use of the mass spectrum. How about IR? IR, Chen Wei-Ho. You haven't tell anything, right? Chen Wei-Ho. So what you get in the IR?
係咪咩 functional group 啊？
Yes, it is from, you may get to know the presence or absence. It's very important, right? Of the functional group based on the absorption spectrum, the IR absorption spectrum. So if you have got some absorption peak and you need to check against the characteristic wave number to get to know what bond stretch will be found, and use this information to determine the functional group's presence or absence. Okay, so of course absorption peak there, the presence of functional group. If you check that wave number, no absorption peak, which means no such functional group. So IR spectrum is very special. You need to know something about the negative one. Okay, even though you check for the absence of a certain functional group, you may need the help of the IR. Okay, can you get my point? So you get the overall picture first. And for the instrument part, okay, including how many parts are there, what are the functions, etc. For IR spectrum, you need to know it. For the mass spec, so far we still do not have much chance of asking the details about the parts, but you should know that they are basically 5 parts for mass spec, and each of them will have its function. Wen Ziwei, do you still remember the 5 parts? You don't know the 5 parts of the mass spec? What are 5 parts? Forgotten. Okay, so how can you get the fragments? Just trace back, even though you forgot the 5 parts. You may base on the information, and you can trace it back, the information. So what is that? So you type, how can we get the fragments? You forgot. The fragments is in form of the cation, right? So how can we make the cation? I do something to it. So what is that? Anyone who can help? Shall I give you one hint? Now you take a look on the basic structure of this. First of all, what is that? Vaporization. And then vaporize the sample and then forgotten. Number 2, electron beam. So what is the use of electron beam? Is to ionize the molecule, okay, by electron bombardment. So the electron gun, they will hit through the molecule. Okay, they will try to hit the molecule and kick away one more electrons to form ion. So what the ion it is in terms of positive charge, and because of that, we have got some slits, okay, carrying a negative electric charge. So what will happen? They will help accelerate, speed up the molecules. And second, I have got this not a magnet, it is electromagnet. Electromagnet can be can adjust itself the magnetic field by the difference in the current, okay, the current flow the coil, and then it will give you the magnetic field of different strength. It will help bend those positive particles, the deflection, okay. So you may see that deflection, this one, okay, change a angle. They turn in a corner. So this is the what? Deflection. And finally, number 5, this is what? Detection. Do you still remember those? If you forgot, just read the pages again. Okay, I don't know whether or not this will appear in the short questions. Okay, just ask you one point. Can you get my point? So you will get that 1 mark based on the structure. You may not need to memorize the whole flow of every description of those parts, but please prepare that you may have a very short response question asking each part. Okay, give me the name, what is that, etc. Okay, can you get the point? If you know what is happening, shall we take a look at the questions now? Question 50, unit 54. Calculate the molecular formula of X. So based on this information, what you would get? A1, you take which data? What data should be used? Tell me what data should be used. So you take a look on this. This is on this part, okay? 62.1% of carbon, this one and this, right? I use this to calculate the empirical formula. How many of you have forgotten the way to calculate the empirical formula? Please put a cross. For those who remember, please put a tick. Just 4 of 6. How about the others? Without response. So what will be the first step? Somebody who you forgot, you just left away.
係
李健朗、文希、余子豪。You forgotten, right? 余子豪。Oh, quite a number of you forgot. So empirical formula. So first of all, what is that? What is the definition of empirical formula? It tells you the formula of showing the elements in simplest whole number ratio. Okay, so how will you make that? Indeed, you cannot just directly divide, make a ratio between 62.1, 10.3, 27.6. But the reason behind is that each carbon atom, hydrogen atom, and oxygen atom, they are of different mass. Okay, so you need, from the formula, you get to know the number ratio, okay? Number ratio. So you have to do one action. What is that? So in the past, you would use the word assume there is 100 gram of the compound X, right? So can you get my point? So you may get, you may draw the table, okay? Draw a table and containing mass, molar mass, and then do the division, right? But in paper 2, I do think you may save some time by doing something like this. So mark the carbon, hydrogen, oxygen, and mark it accordingly, okay? C to H to O ratio, you directly do the division, okay? It just tells you the number ratio. So what is that? Just directly put it at 62.1, indeed this is gram, and then 10.3 hydrogen and 27.6 for oxygen, and divided by their by its own RAM, 12.0, 1.0, 16.0. Can you get my point? Directly put it like this, save time. So what's next? Yep, you may get the answer very soon. So what is the simplest whole number ratio? Anyone can tell? Three to 6 to 1. So tell me that 3 data first, okay? How can you get it as 3 to 6 to 1? What are the 3 data? Yeah? It's not a integer, right? 3, 5.
除再細嗰個係嘛？
Yes, that's right. 10.3 and 1.725. So remember, never do the approximation here. So what is meant by approximation? Somebody would love to do it as 5 to 10 to 2. Okay, so if you use this, you may find the ratio not correct. So it is much different from what somebody else suggested, just like Peng Gahou. You may find it as C3H6O, C3 to 6 to 1, right? It is much different. Can you get my point? So never do the approximation here. So mark it here. Never do the approximation. And many of you, maybe some of you outside, I can also spot some students who just do that wrongly. So how will you tackle the problem is to divide it by the smallest number. So this is the smallest number. So you may find 1.725. And before you do any type of approximation, So remember, leave that approximate. You can still do the approximation, leave it at the very end. So what you may get. Can you tell me the exact number of test 3? Is of course is 1. How about the other 2? What do you get about that 3 data? So the exact, is it exact number? Is it exact number? Not so exact, 5.97, right? It is 3.00, something like that, right? So n into 1. So you may get it at 3.0000 to 5.97 to 1.0, which is equal to 3.6.1. So remember, the approximation can be done here. So this is 3.6 to 1. So the empirical formula of x is C3H60. Remember to leave this at as your final calculations, right? You need to tell me your conclusion because you are going to find out the empirical formula. Questions? Easy, right? Your memory, just go back. Can you recall your memory? Have you recalled memory? How about those who make a cross? 盧少華問希 Udino, recall your memory about that? Yep. So capture the screen if you want to have it for your further retrieval. Okay. Well, next is to is that clear? Okay, so go back to the other part. Now take a look on the second questions. Calculate the molecular formula of X. So what information do you get? Shall I invite somebody to continue? Yep, from the mass spectrum, what you will get. There is a pairing peak of mass to charge ratio equals. Yep, can you get the point? I just started something at the very beginning for all of you. So what is that? Shall continue the remaining for me? Yeah. So what is the mass to charge ratio? Don't jump to conclusion so fast. Tell me. You have to tell me data first. What is that? And then, could you please finish the remaining for me? Of 58. So what can we count? The RMN of X it is said to be 58. So you use this data, yeah, you do the same thing. So let the molecular formula of X be the multiple of the empirical formula. The multiple with you need to get to know what is n. So n times 3 12.0 plus 6 times 1.0 plus 1 times 16.0 equals 58, and you are going to find out what is n. So what is that? What's that n? So what is that n? 36, 42 is 1, okay? Is 1. So the molecular formula of X is C3H6O, the same, is it? You just calculate 36, 42 plus 16 is 58, exactly the same. So the empirical formula and molecular formula is you talk about the same ratio and also the same number. What is the interpretation of the following two results? Strong absorption peak at 1720 cm per centimeter in IR spectrum. What information? Just write down the later half, right? So, according to our practice, you just write in there is an absorption peak. Just remember, there is a astrometry paper which shows what? Remember? What is that? Which shows, yep, it shows the presence of CO double bond. So how will you get that data? You have to check against the given wave number table. But of course, the more you practice that data, that wave number is very characteristic, and you will soon memorize that number. How about the positive results in the 2,4-dinitrophenolhydrazine and silver mirror test? So what is the interpretation? So first of all, positive result in that one shows the presence of carbonyl group. And this silver mirror test, a positive result, show it as an aldehyde, but not ketone. So you are going to get that two data together. So what is the conclusion? The compound contains an aldehyde group. Can you get the point? It's easy, right? How about number C? Write all possible structure for the ions for the peak at mass to charge ratio 29. 29 is you can relate it to C3H6O and try to get what can it be, aldehyde. So you use one as aldehyde. So 3 carbon but 1 aldehyde, the answer is very obvious, right? So this is CH3, CH2, C double bond OH, right? It is a propane now. Being the RMM being 58, so you make it 29. So you may chop at somewhere. For example, chop it here, right? Chop it here, and you may find this one is 29. How about this? This is also 29. Okay, you get a point. So you may have two types of the ion. So I would like to check ion. So CH3, CH2, and middle bracket with a plus. So remember, plus. And what's next? If you show this, how will you show this? So it may be H, C, double bond O, plus. So remember, this is very important. Okay, need to show a positive sign. Why? Because it is the fragment cation, as said before, right? So you use the electron gun to hit the molecule, and then they will kick out that electron. So based on the molecular ion being positively charged, after some fragmentation occur, the cation will also be formed, but smaller one. So it must be carrying a positive charge. Can you get a point? So take a look on E. It is the structural isomers of compound X. Suggest how to distinguish them using mass spec. There is structural isomers. So circle that one. Structural isomers. So what can you think of? C3H6O. Or you may get at the other one, right? Which is acetone. So propanol. So you use this to check against propanol and to think of the mass spectroscopy, how you distinguish them. So remember, distinguish. It is something like sense of comparison. Okay, you need to do some comparing work. What I want to refer to is to check. So what information you get in the mass spec? You have different peaks, right? So you have to identify some characteristic peak in which one has while the other one doesn't, and vice versa. Can you get my point? So start from this. Samson, can you please suggest some very typical mass to charge ratio where to show one chemical will have a certain peak, the other one will not?你同 Sledge
呢個我唔係好識喎。
You don't know? So how would you chop? Now just refer to mass to charge ratio 29. How would you chop the bond such that we've got 29 in propanol? Yep, this is the place, right? Propanol. So you chop on propanol so as to get the mass to charge ratio at 29? Can you get my point? You do the same thing. You chop. Can you make it at 29? Is it possible? So this is the first answer. CH3CH2COH has a peak at mass to charge ratio 29, representing the fragments ion CH3CH2 middle bracket plus. While how about the propanol? You know that this is the commonplace way to chop, but even though we chop it like this way, we can never get it 29. So you may say it is structural isomers, which is propanol. Does not. So you use this to distinguish. So remember, you need to compare. So you this one you have it and you don't have it, right? So you may use it to compare. Can you think it in reverse? Can you check one characteristic peak where propanol has the peak while the propanol doesn't? You do the same thing. I just chop it for you. For example, I chop here, right, a very authentic number, which is 43. Yeah, that's right, 43. Representing the fragment ions. It is CH3CO plus. Remember, every time while you mention the fragment ions, you have to make it positive charge, while propanol does not. So using this part, you may answer either one, okay? It is possible. So this time, the structural isomers, they have a peak showing CH3CO plus fragments, but propanol doesn't. You got it? Now, shall I, any questions so far, this part? So take a look on question 2, 2A, 2A, they are more or less similar. Shall I skip that? or you use the own method to calculate this? It's easy, right? Very similar. A little bit different. Sorry. It's this. Somebody who already forgotten this part. What is that? A complete combustion of 6.0 gram of compound Y produces 13.2 gram of carbon dioxide and 7.2 gram of water. This part, okay? This part is a very special part. It is different from the first question. You use a combustion data, and this time you may get the IR spectrum. They calculate the empirical formula. The first start is a little bit different. So how will you make the first start from the combustion data? 6.0 gram of compound Y. Yeah. How to get mass of? So that means you are going to find out the mass of carbon, mass of hydrogen, and mass of oxygen. Is it that 3 again? Yeah, very often. Very often is that 3. So how will you get that? So mass of carbon, it is what? The mass of carbon, how you get? Yeah. Where do you get the carbon? It's all from, yes, all from CO2. You may get it from CO2, you may get that carbon. This carbon mass is the same as the carbon in the empirical formula of Y, in the compound Y. Okay, so what you will get, which means that we have got 13.2 gram of CO2, we have got some it is from oxygen and some is carbon. So how you get that? You are going to calculate the fraction by mass to calculate. C, we've got O, right? Altogether is CO2. So fraction by mass. So we have got 14, is about 12. For carbon, overall is 44. So what you get? What will you get? It's about 3.60 gram. So you do something similar for hydrogen and oxygen. So hydrogen, so what will you get? Hydrogen, water, right? 7.2 gram of water. So you use this 7.2 gram of water. So again, it's very similar. Water, we've got H and O part. So altogether, it is 7.2 grams. So of course, not all comes from hydrogen. So you need to make a ratio. So about 18 grams of water, we have only got 2 grams of hydrogen. Now 16 grams is also such that we can call it H2O, right? So what we will get is about 0.80 gram. And what we will get is about the mass of O. So you go back to the questions about mass of the Y. It is about how many grams? It's 6 grams, right? 6.0 gram. So we have got 3 parts. It is carbon, it is hydrogen, and one is oxygen. So carbon, you just calculate it's 3.60 gram. Hydrogen is 0.80 gram. How about this? How do you make that 2 add to the mass of O so as to get 6.00? Okay, it's just a subtraction. Okay, subtraction of data, and you will get it as 1.60 gram. Can you get my point? Now, this is very crucial part. Only by having the calculation of these 3 to get to know the carbon, hydrogen, oxygen mass, can we proceed. Next is to draw the table, right? According to Form 4 knowledge. So you may save time, but writing such CHO ratio equals 3.60, 0.80, 1.60. You just copy that down. And carbon, we've got their own RAM, 1.0. Oxygen is 16.0. You do the same. So what will you get? It is 0.10 mole, right? How about this? It's 0.80 mole. How about this? It's 0.30 mole. So what will you get is 3 to 8 to 1. Okay, the empirical formula of Y is C3H8O. So this is the first part. Do you still remember? The most difficult part, or maybe the frequently forgotten part, is this, right? You are going to use the combustion data to calculate. The molar mass of compound Y is in between 55 to 65. Okay, so are you going to solve an inequality? Somebody would love to, especially 1GY. So what you get is about the let the C3H8O be the molecular formula of Y. So as the RMM of Y is between 55 and 65. So somebody, right, would love to solve it like this. It's up to you, right? It's up to you. Somebody would love to write such to tell me that you are so good in mathematics. But if you don't know how to solve it like this, still don't worry, because what I want to focus is to get n is equal to 1. All right, can you get my point? So you need not do that inequality. Instead, you are going to find out you are going to find out is n is equal to 1, and that is the key. So the molecular formula of Y is C3H8O. C3H8O. So you remember the data for further use, okay? Remember, whenever you have got the molecular formula, that one will help you build up the molecule again. What I wanted to tell is about the structure. I know the structure. I want to know the structure. So what we observed in the positive test of the excited potassium dichromate test? Positive result. So the color change, go back to Form 4 stuff. There is a color change from orange to green. What we observe in the positive test of this, we will have got a formation of red or orange or yellow precipitate. Okay? C, from the infrared spectrum, deduce the bonds present in compound Y. Deduce the bond, infrared spectrum. So you may check the over the spectrum first of all. Bonds presence. You may think of this one, right? Which part? These, right? How about this? Remember, most of the carbon compound we have this. So what is that? It is CH bond. How about this? OH. Remember, because you will need to show the bond, so you are going to write down O and then single bond H. At IR spectrum, you are going to determine the stretching frequency of the bond. So which means bond here, the bond. The focusing point is the bond, but not writing down OH. OH, I don't know where's that. You're going to write down O, the single bond H bond. Similarly, if you have been asked about 1700, right, very often here, right? So you may show the absence of CO double bond. So you may find that I intentionally show the bond. Why? Because it is the principle of IR spec absorption frequency of those bonds. So go back to C part. Go back to C part. Deduce the bond present. Deduced the bond present. So you may find strong and broad absorption band BND, but not peak, because the shape of this is like a band instead of a peak. So you mark it as band. So how you know it's a peak? Peak is somewhat narrow, sharper, okay? This peak, but band is something like this. Okay, it's different. So absorption band. Just copy the range on the table. Shows the presence of, I just want to save some words in expressing in English. Shows the presence of OH bond. So within that range, you know, it is somewhat alcohol. Of course, you may write down CH bond, but it's not characteristic. So I just skip that. How about D? Because I write down bonds, so strange. This part I don't want that because it's not so characteristic. It's not characteristic. It's a 3095 cm that will show the presence of CH bond. all possible structure of Y, all possible. So we have got how many carbon? It should be C3HHO, right? With hydroxy group. I said it's hydroxy group. But for B part, it's not the positive result. Take a look. Not is a it does not react with this. So which means it is not an carbonyl group, no carbonyl group, and positive results in acidify this one. So it is a primary or secondary alcohol, but not tertiary alcohol. Can you get my point? So tertiary alcohol can never be further oxidized by using acidified potassium dichromate. So the only answer you may think of is of first primary or secondary alcohol containing 3 carbon. So this is the first one. This is propane 1-mol. The other one, isopropyl alcohol. Have you ever heard of this term, isopropyl alcohol? So this is the one, propane 2-mol. Where would you heard of this term, isopropyl alcohol? Something about chemistry and daily life. Samson, just have a checking of your common sense in chemistry. Tell me. Anyone who know? 20 students here, but none of you know it. Users, please, but not tell me it's Yi Bing Song. Where will you find it? How is it used in our daily life? Yes, that's right. The hand sanitizer, alcohol pad. On the market, there are 2 main types of alcohol which can be used to kill germs. The first one is, you know, that is isopropyl alcohol. The other one is simply ethanol. Don't you know that? 你同 you dare not say anything. Is it because you just left or you don't know? 陳偉豪
我諗到。
諗唔到. So it depends on how observant you are, right? You just walk around and use hand rubbing alcohol.
唔係都係用ethanol 嘅咩？
You are actually we have got 2 types. We have got 2 types. So based on this, these 2 they are not the same. Okay. So starting from today, you need to be highly aware of the use of hand sanitizer on the market. We have got 2 types. One is isopropyl alcohol. The other one is ethanol. They are not the same. Okay. While isopropyl alcohol is propane 2-mol. They are not the same. But similar function. They can use, it is used to kill germs. Questions? Now we have got some 7 minutes. It's about 20 minutes left. We would proceed to 55 now. It will be a little bit hurry, but don't worry. I would not talk too much because one questions when we leave you guys to do it by at home if you can manage to finish them, or it's 55. Can you see that? Yes, this is the one, 55. Dioxin is a very toxic material. It raises the public concern, such as 2 sources of dioxin. where you get the dioxin source. Two sources, tell me. One of them, it burns something, right? During incineration. So you would say raise material containing chlorine. Transportation. Lack elaboration. I would not give you marks. For example, burning PVC. To produce chlorinated, or maybe when you try to manufacturing of some chlorinated product, which is organic, of course. At high temperature, you may have a risk of producing dioxin. Dioxins is just a family of the chlorinated ring structure substance. So we will say dioxins. So how about number 2? Suggest 2 harmful effects of dioxin to human health. Carcinogenic, right? First effect, cancer causing. What else? What else can you think of? Whenever it is something organic and you absorb to your skin, they will interfere something. They will damage. They will, for example, interfere with hormones. It will damage the immune system. No, respiratory system is a very, indeed, it is just a long-term effect of inhaling dioxin. And 3, or maybe even, maybe to you need to highly aware of it, it will cause some reproductive and developmental problem. If you take in too much dioxin, it's just a long-term effect to you, but not chronic effect. You know what's that? Chronic or long-term? Chronic, atonic, you know the meaning of the actual chronic, you know it? C. Something about English. Now, what is a suitable method to determine the concentration of dioxin in the air? You use what? Dioxin. Long term. The answer is, first of all, GCMS, right? So what is it in full term? Gas chromatography hyphen mass spectrometry. Short response question. I've seen it before in DSE. Just you write down this one, spell it correctly, you can get 1 mark. High CP value. Number 2, sulfur dioxide is commonly found in wine. Its concentration is regulated by the law. So just one purpose of adding sulfur dioxide in wine. What is the use of adding SO2 in wine? No. 雍正男 do you know?
係咪咩防腐劑嗰啲嘢
In English, what's that? How you call it?
？Preservative 啊
Preservative.
？OK。
preservatives. Okay, so as a preservatives, or you would say that is a type of antioxidant, 抗氧化劑。防腐劑。So don't worry too much about the word 防腐劑 is always equal to somewhat not edible. Okay, indeed, some preservatives can also be edible. For example, salt, right? Salt is also a type of preservatives. Don't you know that? For example, some salty fish, right? Some salty fish, if you want to preserve a salty fish, you add a large amount of salt. It's a very basic preservatives. Because I would like to drive away the water inside the food, and so that the bacteria cannot stay there. Okay, it is not a suitable place for them because if they stay there, maybe worms, you stay there, the salt will also drive the water away from their body and will kill them. So remember that term. So just two methods for determination of concentration of alcohol in wine. Two methods. How will you get that? Alcohol, ethanol in wine. You're going to do somewhat like titration, right? Titration with standard aqueous solution of what? You use some mild oxidizing agents like iodine, or you use the word IR-SPECT together with help. So remember, IR-SPECT is just used to check the presence of the hydroxy group only, but not the determination of concentration. So if you want to do such, it is a series of tests, number 1 and number 2. Can you get my point? You do it number 1 and number 2 all together. And C, a driver is suspected to have a drink driving. He breathes out a sample of air, which can give a color change of breathalyzer. Oh no, what is that? We have got two types of breathalyzer. This is a very traditional one, but not a digital one. Digital one, it is made up of fuel cell. Okay, it is used to, is for you to get the digital data, right, based on the concentration of alcohol content. The higher the alcohol content, the higher the current flow that you will read the data bigger. How about traditional one? I use what chemical? Potassium dichromate. So what will be the color change? A very authentic questions. Orange to green. Okay, orange to green. Oh, we're still. Here comes the questions 2. Write the only equation for the reaction in the color change. You forgot. Spend some time on it and tell me the answer. So you may check it. 3R2072 minus. Yes, 3 plus. Cl3 plus. And then, so I need the ionic equation. First of all, you write a half equation, and then how about the next half equation? And last but not least, what is the final equation? Now because you're asking for the full ion equation, but not half. So what will be that? Do you know how to balance that? So what will be the answer? The answer is 3 alcohol. Now you have been asked to write it down for many, many times. Anyone who don't know how to solve, please put up a hand, let me know. Anyone who don't know how to solve this? So the tricky point is to calculate those water and hydrogen ions. You need to check the molecule inside as well, because we have got O and H containing, which is rather confusing. But this is that should be solved in a very, very later stage. The first stage should be solving the ratio of dichromate and the ethanol. Okay, it's 2 to 3 mole ratio. And you use the half equation method. You better use half equation method to see the electrons to have a start. It's easier start. Use half equation, please. Okay, this is what I like to remind all of you. Question 3. A chemist is going to analyze a 0.1 cm³ mixture of volatile substances by chromatography. He wants to separate the components in the mixture. Suggest what chromatographic techniques should be used. So take a look on the word volatile substance. And second is about a very small amount of mixture. So what is the chromatographic technique? You can be vaporized, so you use gas chromatography. Okay, so because that material can be vaporized, right? So you can see in small amount. So this is the techniques. By injecting the sample right into the gas chromatographic device, and then you heat it for some time to vaporize the material and let it pass it through what? Mobile phase. What is that? You pass through the stationary phase using what? Using carrier gas. So somewhat inert gas, okay? An inert gas can help to carry those volatile substances and let them pass through the stationary phase. So it depends on the different absorption and going through the gases, and it's like a distribution. And finally, some gases will be separated and go out at different time. So different time, how we call it? We call that retention time, okay? While for the other chromatography method, we use a retention factor, just like paper chrome, TLC, you calculate a retention factor. This time we use it as retention time. So how to identify the substance that cause the peaks in the chromatography? Identify. So of course you need some literature value to compare the retention time of an unknown peak with the retention time of the standard. Known species. Okay, so this is for question 3. Questions? Now, go back to the last question. Wow, what is that? Yes, I don't want to do it here because time is running short. We just have 5 minutes left. I don't think we can finish them all today, but I will leave you the way to get approach to the problem. And please do it by yourself. Some words you have practiced before. It is the type of yes, back titration. It's not just exam, but also the quizzes. So many versions of quiz that use back titration. Write the equation for the between this one. It is very simple. It is HCl to form ammonium chloride. Color change at the end point as step 4. So take a look on that. Nitrogen in G oxidized to ammonium ion and convert to ammonia by using this one and absorb the ammonia by HCl. Okay, very long term. And this one, which means it is excess, and use this excess HCl and dilute it and make it 25.0 cm cube and use it to titrate against this. So originally, okay, this is the excess exit, but you dilute it, and this part it is NaOH. So you add methyl orange here. So the color change is from red to orange. Remember, whenever you use methyl orange, the aim point should end as orange. It's just the mixing of the two color. Okay, whether it is red to orange, yellow to orange, orange is still at the end. And finally, this question, C part. You have to do it in reverse, as I repeat to you many times. Step 4, do it in reverse to calculate the answer. So this the percentage by mass of nitrogen in the sample, which is equal to 3.18%. Go home and do it by yourself. It costs 4 marks. Any questions so far? So we have got a very quick review of the last 2 chapters. And this is nearly the end of today's the online lesson, isn't it, right? Once you will see each other in Wednesday, it is in face-to-face. But remember, we have got 30 minutes section. So it will be in a rush. So stick back to the schedule on the new timetable and go to the corresponding venue timely. Okay, I will need your cooperation. Timely proceeding to the classroom. It may be either your classroom, it is 6. Which classroom can you tell? 6A is 6B, I forgot. Because one class is 6A, one class is 6B. And then we need to have a Chem 1 class. Oh, Chem Lab for day 4. Chem Lab, first of all, Chem Lab. And then for the remaining classes, for E1 is 6B classroom. Okay, very similar to last year, right? Isn't it? Now this is, and second, we would start to have a lab section. Okay, first, every first day of Friday, please check. We have got supplementary lesson schedule. Please check. And you need, Friday. So you have to sit back to that lab schedule I've just showed you on the Google Classroom. So please check. And this Wednesday, once we meet, I will give you the labs menu as well. Okay, I'll give you the lab menu. I'll give you a lab menu. Okay, so this Friday, what you need to do is to do 2 labs. One is determine the order of reaction with respect to certain chemical, a very authentic example of thiosulfate with hydrogen ion. The other one is this time it is using microscale. Last time you use it as a macro scale. This time I use microscale. And second is the questions about Arrhenius equation. Again, clot reaction. You need to plot the graph. You know what to do now? Okay. So individual work, because of the epidemic situation, you have to do it by your own. All right. Okay. So it's just the end of today's lesson. See you. Bye-bye.